Hey, what's up guys? This video is for section 8-9, which is factoring and solving perfect square trinomials. This is a short version of this lesson, so it is a short video. But if you guys are interested in watching the full version, the full lesson for this video, you guys can check out my Algebra 1 playlist in my YouTube channel, and you guys can like my videos and subscribe to my channel. So let's go ahead and look at what is a perfect square trinomial and how do you guys factor a perfect square trinomial. So first of all, let's go ahead and look at number 1 and identify if a trinomial is a perfect square trinomial. Now, how do you know it's a perfect square trinomial? When you guys are looking at the first term and the last term, remember that a trinomial has 3 different terms. So this is the first term, this is the second term, and this is the third term right here. So you're looking at the first one and the third one, the first and the last one. Look at the coefficients, the numbers in front of the variable. So m squared, it has an invisible 1, so I'm going to put a 1 right here, and that's a perfect square number. 1 has a perfect square root. Now when you guys look at the last term right here, 64, it must be a perfect square number as well in order to be a perfect square trinomial. But you also have to check that you get the term in the middle when you guys factor, and if you guys try to multiply again, it has to be the same term. So here's what I mean, okay? So first of all, let's go ahead and understand how to factor, and then I'll show you guys how to check. So I'm looking at 1m squared plus 16m plus 64. I am going to put 2 parentheses. When you guys have, or you think you guys have a perfect square trinomial, you start with 2 parentheses. I am going to use the square root of the first coefficient and the square root of the last coefficient. So the square root of 1, that is a 1. So I'm going to put a 1 in the first parenthesis and a 1 in the second parenthesis. That is the square root of 1. M squared, when you guys use distributive property, you guys need to multiply the first 2 terms and you need to get m squared back. So look at what happens here. M times m, that's going to give you guys m squared. All right. Now you guys are going to look at the last term. So the last term is a 64 right there. So the actual square roots of 64 is 8. So I'm going to put an 8 over here and 8 over here. Now you guys need to be careful on this one because the signs, they do matter. So when you guys look at a perfect square trinomial, it has 3 terms and you guys are using the square roots of the first term and the last term, you guys need to use the sign in the middle of the trinomial. So this one is going to go in the first and the second parentheses. Both parentheses are going to be identical when you guys factor a perfect square trinomial. So 1m plus 8 times 1m plus 8. Now those are my factors. How do you check if you guys get the term in the middle? Well, you guys can actually multiply these 2 right here, 8 times 1m, that's 8m. Multiply the first and the last, 1m times 8, that's 8m again. And when you guys combine these 2 terms, 8m plus 8m, that's going to be positive 16m. And guess what? This term, 16m, is the same thing as positive 16m. So this trinomial, yes, it is a perfect square trinomial. So I'm going to put YES. How do you actually write down the answer? Well, you can put the 2 parentheses side by side, identical parentheses, but it's very common to use a binomial squared when you guys factor a perfect square trinomial. What is the binomial squared? Well, I'm just going to write down the m plus 8. Notice, I'm not using the 1 next to the m. I don't need it. But I'm going to use a squared as my exponents, stating that I have 2 parentheses that are identical to this, m plus 8, and a second one, m plus 8. So we do know it is a perfect square trinomial, and my answer when I factor is m plus 8 squared. Let's look at number 3 here. You guys have a trinomial. I'm looking at the first term, 4, that is a perfect square number. 25 is a perfect square number. So I'm thinking, okay, it is a perfect square trinomial. But let's go ahead and factor and try out if it actually gives us the term in the middle. So the first term, first coefficient is a 4. So the square root of 4 is 2. So I put a 2 here, 2 over here, and I need a y and a y. My last term, my last coefficient is 25. So I put a 5 here. The square root of 25 is 5 and a 5. Now notice the sign in the middle. This trinomial has a minus. So that's the sign I need to use in my binomials. You always use the sign, the one in the middle. So let's go ahead and check. So I think those are my factors, 2y minus 5, 2y minus 5. Notice they're identical because this is a perfect square trinomial. So I'm going to multiply the middle terms, negative 5 times 2y, that's negative 10y, and 2y times negative 5, that's negative 10y again. When you guys combine those two terms, we get negative 20y, and we do get the term in the middle. So this one, yes, is a perfect square trinomial, and my factors, or my answer, when you guys factor, is 2y minus 5 with a square. Let's look at number 5. So number 5, I noticed that the first term, 25, is a perfect square number. 16 is a perfect square number. So maybe it is a perfect square trinomial. Maybe it's not a perfect square trinomial. You always have to check, guys. So let's go ahead and take the square root of 25. That's 5. I need the b here. 5b over here. The square root of 16. That's a 4 here. 4 over here. And the middle sign is negative, so I need a negative right here and a negative over here. Now let's go ahead and check if we get the term in the middle. So negative 4 times 5b, that's negative 20b. 5b times negative 4, that's negative 20b. Combine those two, you guys get negative 40b. Guess what? It's not the term in the middle. We have a minus 4b, not 40. So what that means, guys, this is not a perfect square trinomial. No, not a perfect square trinomial. Those are not the factors. You guys say this is prime because you guys cannot factor. You guys do not have a perfect square trinomial. So it is not a perfect square trinomial. So now we're going to look at the second section of this worksheet, and it says you guys want to factor each polynomial if possible. If you guys cannot factor, you guys need to write prime. I want to show you guys number 7 because you guys need to know the difference between a trinomial and a binomial. So guess what? Number 7 is not a trinomial. So do not say this is a perfect square trinomial, but it is a binomial. I notice in the middle I have a minus. So this one might be a difference of two squares. You guys have a minus in between, that's difference, and you guys have a binomial with two terms. I noticed that 3 can actually factor out from the binomial because 3 goes into 3 and 3 goes into 147. And when you guys factor out a 3, notice we have a p squared minus 49 inside of the parentheses. The p squared, it has an invisible 1. So looking at that binomial, look at this coefficient. 1 is a perfect square number. 49 is a perfect square number, and you guys have a minus in between. So factoring the difference of squares actually works here. You guys can actually factor that binomial. How do you do that? Well, you guys do two parentheses like this. You guys are going to use the square root of the two numbers, the two terms. The square root of 1 is 1. And you guys need a p next to the 1. You put a 1p over here. And the square root of 49 is 7. So you guys put a 7 here and a 7 over here. Now, here, it is not a perfect square trinomial. It's a binomial. So when you guys have a difference of two squares, you guys need to use different signs, a minus and a plus. This number, 3, you actually have to bring it down. So you guys are going to bring down the 3 outside of the parentheses. Now we don't need that 1 next to the p, so I'm going to clean up my answer. I have a 3 times p minus 7 times p plus 7. I am not using a p minus 7 squared because the two binomials are not identical. They have different signs. So this one you can factor. Those are the factors. 3 is a factor, p minus 7 is a factor, p plus 7 is another factor. Number 9, you guys notice that the numbers, I'm looking at the first one, 50 is not a perfect square number. 50q squared minus 60q plus 18. 18 is not a perfect square number. But I noticed that you guys can actually divide everything by 2. You can factor out a 2. And if you guys factor out a 2, notice that inside of the parentheses, 50 divided by 2 is 25, negative 30 divided by negative 60 divided by 2 is negative 30, 18 divided by 2 is 9. Look at the first term, the first coefficient, 25, and the last one, 9, are perfect square numbers. So I'm thinking this is a perfect square trinomial. Trinomial because you guys have 3 different terms. So I'm going to set up my 2 parentheses like this. I'm going to use the square root of 25, and that is going to be 5. So square root of 25 is 5. We need a q here. 5q over here. The square root of 9 is 3. You guys put a 3 over here. And since this is a perfect square trinomial, you have 3 terms, I need to use the sign in the middle for both binomials. So you guys put a minus and a minus. Now you guys need to really check. Do we get the negative 30 back if we multiply? So you guys can check by multiplying the ones in the middle. Negative 3 times 5q, that's negative 15q. And 5q minus times negative 3, that's negative 15q. When you guys combine those two, we get negative 30q. So guess what? Yep, we get the term in the middle. So since the two binomials are identical and we do have a 2 outside of the parentheses, my actual answer, we can write it as 2 times 5q minus 3 with a square. So you guys have a binomial 5q minus 3 squared with the 2 outside. So that's my answer for number 9. And the last one I'm going to do here, guys, we do have 2 different variables. I'm looking at the trinomial. The first term 16, that is a perfect square number. The last coefficient 81 is a perfect square number. So maybe this is a perfect square trinomial because it has 3 terms. Trinomial means 3 terms. So I'm going to start with my 2 parentheses. I'm going to use the square root of 16. So square root of 16 is 4. I put an a right here, 4a over here. The square root of 81, that's a 9. But notice that 81 has the letter D. So I'm going to put a 9 with the D and a 9 with the D over here. Now, since it is a perfect square trinomial, maybe it is a perfect square trinomial, I'm going to use the sign in the middle for both parentheses. So I put a plus and a plus over here. I need to check if we get the term in the middle. So let's multiply. 9 times 4, 90 times 4a. That's going to be 36ad. Remember the letters, the variables, they have to be in alphabetical order. A is before D. And if you guys multiply 9a times 9d, that's going to be, 4a times 9d, that's going to be 36ad. Now you guys combine those 2 terms, 36 plus 36, that's going to be 72ad. So we do get the term in the middle. So this is a perfect square trinomial. So my answer, you guys are going to write it down as a binomial square and keep the variables that we have. So we have 4a plus 9d with a square right there. Okay guys, I don't want to make this video too long. So let me just explain. If you guys try to factor using perfect square numbers, so you guys think you have a perfect square trinomial, and you guys check your middle term, and this term is not equal to the middle term, that means that you guys cannot factor, okay? Always check that you guys can factor out a GCF, an actual number like a 2 or maybe a 3 or maybe a 5. But if you guys cannot factor, if you guys cannot find anything that will multiply to that trinomial when you guys use distributive property, you guys can actually write down the word prime. Just because the first time doesn't work, do not write prime number. Don't jump into conclusions. You guys have to try. You guys have to check. This is kind of like trial and error. You check, and if it doesn't work, check again. If it doesn't work, check again. Now, if you guys check 3-4 times and it still doesn't work, well, you guys can actually write down prime. But I have a lot of students that they actually stop the first time and they say, oh, this is prime, this one's prime, this one's prime, because they don't want to try something else. So make sure you guys do that. Try something else, try different numbers, and just check if you guys get the term in the middle. So make sure you guys are doing your work. Make sure you guys are checking Google Classroom. Make sure you guys practice, and I'll see you guys later.